Okay, we want to do a demonstration of the Pulse Master. This is it, in a NEMA 4 case. Right now it's outputting pulses. Frequency is 696 Hertz. It's got a batch setup of 10,000 pulses, and it's not dropping any pulses. It's just free running right now. So you can see the free run, the batch pulse count, what the frequency is, and it's not dropping pulses. This is what the pulse train looks like coming out on the scope. I'll give it a few more. This is the low level signal level output. So this is used to drive the PA6. Says the scale here is 0.1 volts. It's on I got times 10 scope probes, so that's actually 1 volt. So it's a 2 volt output. And if I ground the input, you can see that that's symmetrical around the ground. So the ground is actually here. So it's a plus and minus signal. The DC component is removed to drive the PA6. Okay, so we're all set up to do a batch. Let me arm the Pulse Master. That turns off the pulses. Go to a flow computer here. Nice folks at FMC in Corpus have loaned me a flow computer, so let me change my other hand here. And we'll start a new batch. Okay, batch is started. Go back to view. Current batch data, the totalizers, and the pulses. We can see that those are all zeroed out. No pulses coming out. So what we'll do is we'll start to run the batch. See the pulses coming out on the screen. And you can see the totalizer counting up here. So if I want, I can actually stop the batch in the middle. You can see right now the count is 8216, and it's halted. If we go over here, you see that the count is 8216 on the A pulses, B pulses, and total pulses. So then we'll start it back up again. Again, see the status change up here from halt to now it's in batch mode. Got to 10,000. Stopped outputting pulses. And we got to 10,000 pulses on the flow computer. So now let's do the same thing, but instead let's drop every 10th A pulse. You can see the entry limits are on the display. So we're dropping A pulses. We're going to drop every 10th. And the valid entries are greater than or equal to 0 or less than 100. If you enter a 0, that'll turn this feature off. So just to let you know. And then the enter button. Now we're showing that we're dropping A and the 10th pulse on the A pulse, on the A train. Okay, so now I'm going to continue the batch on the flow computer and just restart it over here. Now we're armed on the display and we're batching again. And you can see that every 10th pulse is dropped on the scope. And if you look over here, you see the A pulses counting up. And you'll see we ran 20,000 total pulses now. 10,000 from the first batch, 10,000 from this batch. This batch had the A pulses every 10th pulse skipped, so that's only 9,000 pulses came out on the A, another 10,000 on the B, but the missed A pulses was 1,000. Okay, so that's the batch feature. You can skip B pulses also. And when you skip B pulses, if you were skipping A pulses, that turns that off. So we'll do 50, skip every 50th B pulse. Okay, we're at the end of the batch. We'll go ahead and arm it again. That clears the totalizer. And we're running again. Now we're skipping on the B pulse train. Let me change the trigger over here to the B pulse. Oops, wrong way. There's our 10,000 pulses. You can see here that we skipped 200 pulses. Now it says 199 here because we didn't get another A pulse, so that we saw that we missed the last B pulse. The B pulse was the last one to be seen. So we're 200 down on the B pulses. So that's the batch function. Now we'll change to the phase adjust function. The phase adjust mode. Again, the frequency stays the same. And the phase adjust between the two pulse trains is 90 degrees. We'll go ahead and make it a little easier to see the actual phasing. With the different buttons here, you can make it 0 degrees. You can see how the display changes. So now they're in phase, 90 degrees out of phase, and 180 degrees out of phase. And if you want, you can adjust it up or down in 10-degree increments. So you can watch the display, watch the scope display also. And you can see the phase relationship changes. 130 degrees now. So they're in phase again, and then you can 360, they're in phase the other way. And 180. Go back to 90, or you can just push the 90 button. That'll put them back in phase. Okay, the adjustments here, they're actually encoders. They're not pots. So it's totally digital operation. The fuses here are 100 milliamp fuses, and they fuse the high voltage. So there's two different outputs here. The low voltage is to drive a PA6. That's the voltage we were looking at before. And the higher voltage is a straight 24 volt pulse output on both the A and B pulse trains. And that's the Pulse Master.